Thanks for watching the screencast. The objective for this screencast is learners will be able to determine whether a discrete relation is a function. So a relation is simply a set of ordered pairs. One way to write a relation out would be to simply just write the ordered pairs as a set. In math, we often write sets, starting with these kind of curly brackets. It's the same symbol you would get on a keyboard if you held down Shift and hit the square bracket button to the right of the P. So a set of ordered pairs might look like this: 0, 0, comma, 1, 2, comma, 3, 0, comma, -4, 2. That could be one example of a relation. One way to represent a relation is by giving just the listing of those ordered pairs. But there are three other ways shown below. Now it's worth pointing out that all of these are examples of discrete relations. And a discrete relation is a relation with a finite number of ordered pairs. Finite generally means countable. Now this table, graph, and mapping all show the same relation. They all show the same ordered pairs, the set of ordered pairs, and they show it in a different way. The table simply shows each ordered pair as a row of the table. So, for example, one of the ordered pairs in this relation is 3, 5, -3, 5 rather, -1, 2, 0, -3, 0, 1, and so forth. Another way to show it would be with a graph, by simply plotting the ordered pair on the coordinate plane. And it's worth pointing out that this was called the x-axis and this was the y-axis. So the ordered pair -3, 5 relates or is corresponding with this point here. And the ordered pair 0, -3, for example, has an x-coordinate of 0 and a y-coordinate of -3. And then the third way is called a mapping. So in a mapping, the sets of x and y values are shown in these little sets here, almost like ovals. And what's important is that the ordered pairs are shown by the arrows that connect the x values to the y values. So this -3, 5 is shown by the arrow that connects -3 in the x set to 5 in the y. The 0, -3 is shown for the arrow that connects 0 in the x to the -3 in the y, and so forth. So these are all different ways to indicate relations and to organize that information for you. Now we call the set of input values, or in other words the x values, we call that the domain of the relation. And we call the set of output values, or in other words the y values, the range of the relation. So one thing you could do is you could list the domain and range out simply as sets themselves, and I'll show you an example of that. We'll use this relation here for the example. For this one, I would say that the domain is the set. It's a set, so I'll use that curly bracket again, of all the x's. 2, 3, 6, -4, 0, and +4. It's a set. It doesn't necessarily have to be written in order from least to greatest. You do get a little bit of mathematical cool points if you do that, I suppose. Okay. And then to list the range, well, the range is the set of all of the output values, all of the y values here. So to write that set, well, I've got 5, I've got 0, I've got -1. Now listen, I don't need to write 5 again. All I'm trying to do is give you a list of what's in the range. The fact that it showed up more than once doesn't really mean it needs to be included more than once. I should get my -2 in there. And just like with the -1, I don't need to write that again either. So here's the range. Now a key idea here is that a relation is a function if every element of the domain, or if, in other words, if every x is paired with exactly one element in the range, one y. Does every x have only one y? So the example we just looked at is a function. Every x has only one y. When x is 2, y is 5, and that's it. When x is 3, y is 0. When x is 6, y is -1, and so forth. This example here is not a function. And the problem ordered pairs are these two. These two ordered pairs suggest that when x is 3, if I were to write what y is supposed to equal, well, I don't know. I don't know if I'm supposed to write 2 or if I'm supposed to write 6. So there's some doubt. There's a question mark here. If there's any x value that causes two different y values, then we would say it's not a function. Okay, it's time for you to try this now. My question simply is this. Here are 6 discrete relations. Which ones are functions? Which ones are not? So what I'd like you to do is to pause the video, try to decide for yourself which ones are functions and which ones are not, and then when you're ready, hit play and we'll check it out. Alright, how'd you do? Let's see, let's try and find the functions first. I'll do those in red. If I look at this one here, I see that every x, -1, -2, -3, -4, -5, has only one y value. You know, -1 goes with -2 and nothing else. -2 goes with -3 and nothing else. -3 and -4 as x's both go to -4, but that's okay. As long as every x is predictable, as long as you know exactly which one value every x goes to, it's a function. This is a function. Let's see. I think this is a function here, the mapping up here. Every x value, -3, -1, 5, and 8, I know exactly where they go with no repeats. And let's see. I think this is a function too. I think this one's a function. Okay? Because every x value goes to only one y value, and it's actually fine that they go to the same y value, but every x value here has a predictable outcome. I see 2 that are definitely not for sure. One of them is this input here, or this mapping here, and the problem is that when x is -2, I don't know if I'm supposed to go with -1 or if I'm supposed to go with 8. Those are both ordered pairs in the relation, but since not every x is predictable here, I have to say this is not a function. Maybe I should use x's instead of checks. This one's not. Here's another one that's not, right here. And I actually see a couple of problems. One is that when x is 3, I get 2 different y values. Another one is that when x is 4, I get 2 different y values. So let's talk about this one up here. This is kind of an odd example. I've got 2 different ordered pairs that indicate the same x-y connection. So the question I've got to ask myself is, when x is -2, do I know exactly what y is supposed to be? Yeah, even though it showed up twice, I think y is 1. Here's another thing to think about. I see, for the other connections here, there's only one output value when x is 1, y is -2. When x is -1, y is +2 and nothing else. When x is -3, y is -2 and nothing else. You know what? That example with the double ordered pair was a little odd, but I think that's a function. I would say that's a function. Thanks for watching.